All right, now we're working on energy. With energy, I have two ramps that are the same height, and you need to lift a 3 kilogram block up. Which one requires more force? Well, they both are going to go the same height. However, this is a steeper incline than that. Or another way to think of it is it's got a shorter distance, and we know that work is equal to force times distance. So if the distance is shorter, the force is going to be bigger. So A will require a bigger force, which requires more work. And that question is the fact that they both have the same height. Therefore, they both have the same amount of work to do. They have the same mass and everything. So neither or both, however you want to say it. All right, now we have something that is coasting. So Jonas has potential energy up here, and he's got kinetic energy. Down below, he only has kinetic energy. So if we do that equation, same conservation of energy, we have PE at the top, or I'm sorry, PE plus KE is equal to KE at the bottom. So we have mgh plus 1/2 mv squared at the top is equal to 1/2 mv squared at the bottom. Right away, we can cancel out the masses. Even if we don't know his mass, it doesn't matter because there's a mass in everything, so all those masses cancel out. We are looking for the velocity here. We can multiply both sides by 2. And we end up with 2gh plus v squared is equal to v squared, square root both sides. And we have v is equal to the square root of 2gh plus v squared. That v squared does not cancel out, remember. So we're going to plug it in, and we'd have 2 times 9.8 times your height of 4 plus your 5 squared, and you get an answer of 10.2. Next up, we talk about two identical objects. So that means they have the same mass, and they have a velocity of 4 and 8. And the idea is that I want you to remember that 1/2 mv squared, if velocity is squared, when you double the velocity, your kinetic energy is 4 times bigger because it's squared. So the ratio of kinetic energies here is going to be 1 to 4. If I had a velocity of, let's say it was 12 instead of 8, if it was 3 times bigger, your ratio would be 1 to 9. If it was 4 and 16, the velocity was, the kinetic energies would be 16, or it would be 4 times bigger the velocity, so the kinetic energy would be 16, because 4 squared is 16. All right, we have another question here about an object falling towards the Earth. Remember that potential energy would decrease as the kinetic energy increases.